There are people around the world who have to travel long distances to get clean, safe drinking water. This is not only a difficult task but also carries the risk of bacteria growing in the water during transportation. So, as a possible cost-effective solution, we suggest the idea of filtering nearby river water which is not suitable for drinking water. That's where bamboo comes in handy. For example, bamboo is cultivated in many countries in Africa, where people have to walk many kilometers to get drinking water. Bamboo is also cultivated in Japan, and is deeply rooted in Japanese life. This time, we're using bamboo charcoal, which has been used to filter water in Japan for about 500 years, and we decided to explore this technology. Bamboo charcoal's porous structure absorbs impurities such as chemicals, heavy metals and debris. And we built a filtration device using bamboo charcoal and other materials that are readily available in African countries. Bamboo grows straight and has joints, making it ideal for creating a filtration system. As you can see in the picture, 5 bamboo tubes are stacked one on top of the other and hung from 4 surrounding poles. Each tube is a container designed to hold one of the following materials: pebbles, gravel, coarse sand, fine sand, or bamboo charcoal. The bottom of each container has several small holes to allow water to pass through. A cloth is placed at the bottom of each container to prevent the materials from leaking through the holes. Next, we tested the filtering capabilities by drawing water from a nearby stream, dissolving acrylic water-based paint in it to simulate muddy water, and running it through the filtration device we built. Here's a photo of colored water in a cup. And here's the same water after it's been passed through the device once. You can see the color change. So, we know this water filtration system works. But we don't know exactly how it works because we can't see what's going on inside the bamboo container. So we made another filtration device out of a plastic bottle that we can see inside. To see if bamboo charcoal is truly effective at removing impurities, 2 plastic bottle devices were made, one with double the amount of bamboo charcoal for comparison. As a result, the device with the increased amount of bamboo charcoal removed more paint in the first filtration step. This proved that bamboo charcoal was effective in removing impurities from water. So we continued the experiment by using the plastic bottle device with increased amount of bamboo charcoal to visually observe the filtration process. After passing the colored water through the filter 8 times, a lot of paint was removed and the water was so clear you could see the bottom of the cup. And we wondered how many more filtrations the charcoal layer could withstand. So we filled another cup with colored water and ran it through the device. After another 8 filtrations, the shade of pink had disappeared, but the clarity was still not high enough to see the bottom of the cup. So, to see if there was any change after that, we ran the water through the filter 2 more times, but the clarity remained the same. Therefore, we concluded that the charcoal layer is effective in removing impurities for up to 16 treatments. However, this may vary depending on the level of contamination in the water. Thanks to the bamboo charcoal filtration system, the water is so clear that you can see through it. But is it drinkable yet? Are bacteria being removed during the filtration process? We've learned in the past that boiling water is effective in killing many types of bacteria. So, to confirm this, we conducted an experiment of bacterial culture. As shown in the photo, agar plates were prepared to test whether bacterial cultures would occur in stream water under 3 different conditions. Those are: A. To observe bacterial culture in water directly from stream. B. To observe bacterial culture in filtered stream water. C. To observe bacterial culture in stream water that has been sterilized by boiling at 100 degrees Celsius for 10 minutes. And D. To observe no bacterial culture using only agar medium to ensure that it was not contaminated by bacteria from human saliva or the air. These media were left at room temperature for approximately 26 hours. As a result, no change was observed in the petri dishes containing disinfected water or agar medium alone. But bacterial cultures were observed in the agar media containing plain stream water and filtered stream water. Through this experiment, 2 things became clear. The bacteria cultivated were from river water, not of human saliva or the air, and disinfection by boiling is effective in eliminating them. We wondered whether this disinfection method could be applied to river waters in Africa, and after conducting research, we found that the major bacteria found in African waters can be killed by boiling them for 10 minutes. The materials used in the filtration device must first be disinfected by boiling, and it is important that the water to be filtered is also disinfected before running it through the device. Otherwise, bacteria may grow in it. In any case, the device will require maintenance after a certain times of use to maintain its performance. However, if each ingredient is packed into a plastic bottle and cannot be removed individually, cleaning will take a very long time. This is when the bamboo filter comes in handy. Because the containers carrying the materials are individually removable, it is a good idea to disinfect reusable materials such as bamboo containers, pebbles, gravel, coarse sand, and fine sand when replacing disposable materials such as bamboo charcoal and cloth. Furthermore, once the bamboo charcoal no longer has the ability to remove impurities, it can be crushed into small pieces and spread on farmland as fertilizer, minimizing waste. Although disinfection by boiling has removed bacteria from the water and filtration has removed impurities, there is still some sediment remaining and the water is not 100% transparent. In this respect, it is suitable for household use such as cleaning, bathing, and laundry, but not for drinking. So we came up with a hypothesis: there must be some solid substance that makes the water's opacity visible. It could be impurities that were originally in the water that somehow leaked out of the layers of the filtration system. It could be sand that came out of the filtration layers. It could be tiny particles of bamboo charcoal. It could be paint residue, or a combination of all of these. If small but visible particles can get through the filter, there's a good chance that even smaller bacteria can live there, like a few that somehow survived the heat disinfection process. We wanted to find a way to separate the sediment from the water and, in the process, remove any lurking bacteria. The answer was distillation. We conducted an experiment by covering the spout of a kettle with a metal cup, as metal has high thermal conductivity, allowing air to quickly cool the steam and turn it back into water. This shortens the distillation process. As you can see in the pictures, the sediment remains in the kettle and the water is collected separately. Needless to say, the water has been disinfected again in the process. The overall process for obtaining clean drinking water is as follows. 1. Boil water for 10 minutes to sterilize. In other words, remove bacteria. 2. Filter water. In other words, remove debris. 3. Distill water. In other words, remove impurities and bacteria. This idea of ours is to reduce the number of bacteria in water, thereby reducing the risk of hazardous health effects to humans. Hopefully, this will contribute to the health of people around the world, and reduce the need to travel far to get drinking water, and free up time and energy for other important things in life for them.